Hello, everyone. We are welcome to the 15th out of 16 classes for this training course. Today we'll continue with pandas. We'll continue with Python on Jupyter Notebook. Right. So I'm going to share my screen now, and then we'll go in straight to working on Jupyter Notebook. So I already have my Jupyter Notebook opened, but a quick reminder to open your Jupyter Notebook. You can do that from Anaconda, or you can, from Anaconda Navigator. You can also do that from Anaconda prompt. On the prompt, you just type Jupyter Notebook. Right, so once you press enter, the Jupyter Notebook will open up for you just like you have on my screen. Okay, right, so we already touched on how to load files from CSV, how to load CSV files. Today we are going to start off with how to load files into Python from our database. The database we are using for this course, as you all know, is Microsoft SQL database. So we are going to load a file from our database. So let's load the file that we created into our database yesterday. So yesterday, remember we created, we imported files from Excel into our database, which is this year's regional DB. So let's load a file or a table from here into our data, into our Python, right? Okay, so before you can create a connection to your SQL DB from Python, you must first of all import this library. And to import the library, it is simply, let me run this on a different cell. It is simply import pyodbc as py. In some instances, you might not have the library already installed on your Python, so you would need to pip install that library. So you just run pip install pyodbc. I already have mine installed, right? So I have requirements already satisfied, but in your own case, you need to start with this instruction. Then next thing is to import the software that you have installed. So you are importing it into this file where you are running your script from, right? Now, to create a connection using this library function, you need a DSN storage on SQL, right? So we need to create that connection to SQL first. And to do that, you will go to your ODBC data sources connection, right? So DSN is data sources network connection, right? So as long as you have installed Microsoft SQL, you would also have ODBC data sources, right, installed on your system. So I'm just going to go to ODBC data source now, and I'll create a connection to my SQL DB. Right, so to do that, you go to System DSN, and then you do Add. So this is similar to like your import-export tool that you used in, transferring data from Excel into Microsoft SQL. So in this case, now I want to create a connection for transferring data from from SQL into Python, right? So we'll pick the data source, which is SQL Server client. So you just need to specify a connection which you would use in your Python or any application that wants to use ODBC data source to connect to your SQL. So I can just say new connection. Right. You can give it any description you like. First connection to SQL database. Right. Then to specify the server, you can come back to your SQL server and just copy the server name. Right. So remember server name, just copy it. Next. You can ignore this, it's optional. Leave this at default. Next. Right, so I like to specify the database I'm connecting to. That should be my US regional DB. Right. Next. And finish. Right, so let's test the data source. Okay, great. So we can see that test completed successfully, meaning that the connection went through successfully. Okay, so this is our connection. Is created here as new connection. So this name, new connection, is what we'll specify in our Python. Right, so I'm going to specify my DSN as new connection. Right, so once I execute this now, it has completed successfully. Right, so next thing is to get my data from my SQL DB. And to do that, I need to specify a query. Right, so the script here will execute this query to get the data from SQL. So let's see our database and check any table we're interested in. So let's say we're interested in the sales table, sales orders table. So we can specify here that select star from sales order. Sales orders. Okay. So because our table name has space in it, then we need to put it in a block bracket way so that it can be recognized as a complete name. So if I execute this now, run.
I think the order has, there is S in the order, right?
Oh, okay, yes, thank you. Yes, thank you. So it's executed successfully now, right? So Python uses what we call a cursor to execute the query and to fetch the data. Now you need to read that data into a table in Python. So we are going to declare a data frame. Okay, we are unable to declare the data frame because we have not imported the library for it. For our data frame, remember the library for data frame is pandas. So we just do import pandas as PD. This PD is just an alias name. It can be anything. It can be it can be it can be any name. It's just using the same concept of table alias like we learned in SQL.
My
Right.
hand is up.
Yeah, I wanted to say you can ask your question.
But what I wanted to ask is that must it be you are using Jupyter, must it be Jupyter that someone will use for this?
No, it mustn't. You can use any Python library.
So I have PyCharm. That's what I wanted to know.
Yes, you can use Python too. It doesn't have to be
Oh.
Python. Yeah. Jupyter
Because
is
I'm
just
thinking that
easier
with PyCharm gives you some word completion, or when you are even doing this import and all those things, gives you some functions to use.
Oh, okay, that's true. That's true. Yeah, but you can use any Python IDE, PyCharm, Eclipse, and the rest of that. But most times people use Jupyter Notebook for data science. Python.
Okay, that's what I was. Okay.
Oh, right. Okay, so now that we've declared our data frame, we want to read the values from our table into our data frame. So our table, we have to use the column name from our table. This is a different column name. So our sales orders table, let's see the columns in there. Yeah, I just did this so as to be able to copy my column name easily. Right. So these are my columns. So the first column is sales channel. Sorry, is order number. So you must ensure it follows the same order, right? So I'm just going to replace some of this. Ship date, delivery date. So each cursor row contains, it reads the table row by row. So each definition of the row contains these columns. So you have to define it within a loop, right? So this is how Python reads data from a table in SQL. So let's just check to ensure consistency. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, then 15, right? So once we run this now, we can collect our data from the cursor into a data frame object. Right, so it's collected into this data frame object. To view the data frame object, you can just say final head, so it will just give us first few columns, first few rows rather. Yeah. Let's read this again into the cursor. Um, select star from this and this, right? Okay, let me use another table. Let's see. I'm going to use customers table now. Customers table has just 2 columns. For this, so customer ID, customer names. Remove this space. Underscore customer. Okay, so we're able to bring from customers table. I don't know why sales table did not work. Hello? Hello? Okay, yeah. So we're able to bring in data from customers table. I'm suspecting sales table did not work, maybe because of the space in the table name also. Um, I can't tell for now, but yeah, this is data from SQL table. Let's just try the customers, the sales orders table once more and see. By after let's rename sales orders table. So sometimes having a space in our column names or table names could pose an error. Unit cost, price, this. We have many spaces. So our next cursor has this, right? And then we execute with that. Okay, but before we do that, let's remove all the spaces. I'm sure it will work now. Let's remove the spaces in our column names. That could be the problem. Mm, Final space again. Right. So let's refresh on the table. Okay, back to our Python script. Let's just remove the spaces here as well. One, two, so we have 14 columns. Let's check. 2, 4, 6, 8, 10, 12, 14, 16. Ah, something is missing. Oh, okay, maybe that was why I didn't write. So I have 16 columns here. Two, yeah, this 16 as well. Okay. Oh, our sales orders has underscore in it. Sales underscore orders. Right. So that was where we were missing. So if we run this now, we should have our table. Let's see. Oh, our table does not contain any data. Wow, sorry. So the oh, okay, oh, sorry, there's no data in this table. So the code is running fine. It's just that there is no data in this table we're importing from. Yeah, so the code is fine. You can see we're able to bring data from customers from the SQL table into Python. Right. So I'm going to show us. I want to demonstrate now how to do regression analysis in Python. Okay. So because of time, I created the script for the class earlier, and then I'll just walk us through it. Right. Um, okay, so this first cell simply shows us how to create a NumPy array, and then how to convert a NumPy array to a data frame. So definitely you have to bring in your NumPy array, NumPy, import NumPy as np. Right, so we can create a table from scratch using NumPy array. So this is an array of numbers. This is also another array of numbers. It can be of names and numbers. Then you combine into a data frame specifying, you combine into a data frame specifying the array and the column names you want it to have. Another option, so this is okay, so this is a way of combining it to form a data frame. So I'm just going to run this now. I don't need this here. Okay, yeah, this is what I want you to concentrate on. Okay, yeah. So data frame reads tables and creates tables as records, record upon record, row upon row. So for you to create a data frame from scratch, you specify your rows in a NumPy array. So this is my first row indicating name, age, name, age, name, age. And then in defining my table to the data frame object, I would specify the column names, which are names, then ages. So once we run this now, once we run to create the data frame, right, you can see the data frame created. And you can query this just like any other data frame or table in Python. Right, so the next thing quickly is to run a logistic regression. We'll be using Titanic data from from Kaggle dataset. to get on Kaggle, you can just, so Kaggle is a competition site where data scientists go to work on data, and it also includes some rewards, but you can learn by working on those competitions as well. So let me show us to get to the data for how to get to the data for this demo I want to explain. Right, so simply check up Kaggle, right? The Titanic competition, right? You can create a profile for yourself on that competition site. But most importantly, if you need data to play around with, you can come to this competition site too and check up on their data. So on Kaggle site, you have an overview explaining to you what the competition and the data you see there is all about. Then for you to download the data, you just come to the data menu. You usually find your data in training set and test set. So you download both. And then here you can see examples of some codes that people have written. You can learn from these codes. You can, download some of these codes and see how others have written their codes, and it's available for sharing. Then this is a forum section. You can also learn from here also on how people have worked on the data for the competition. This leaderboard shows the ranking of various submissions towards the competition, rules for the competition, then teams available within that competition. Right, so our focus here is on the data menu. So we downloaded our data from here, downloaded the train CSV. So once you download, you can then load it as a CSV into your Python. So I have it in my downloads folder as train.csv. So to load into my Python, I just simply call up the pandas library read_csv run. So it's loaded into my variable name declared as Titanic train, right? So I want to confirm that it's loaded. Let's read this again. Okay, fine. So yeah, this is my file. It contains all of this. I can open this file for you as well in Excel so that you can see and confirm that it has similar columns. Right, so you can see your file contains passenger ID, survived, P class, and it contains 892, 891 rows, yeah, without the header row. Right, so for you to, yeah, so just check the column names, they are all complete. Then this not null would help you to know columns that have missing records within them. So for example, age has some missing records, cabin has some missing records, embarked has some missing records, every other columns are complete. Then the D type helps you to know the variable type or the column type. So int64 simply means that the column contains integer numbers. Then in Python, it represents strings as objects. So object simply means that, oh, these are string values or text-based values. Then floats for decimal or floating numbers type. So let's view the data using train.ed. You can see the first few records in our data. Right, so as a data scientist, before you pass this data into your machine learning algorithm, you must ensure data completeness. So you need to work on the columns that have missing values. So we'll be working on the age column, the cabin column, and then the embarked column. And we'll also check up on all other columns to see that they are consistent. So those statistical concepts and some mathematical concepts come to usefulness at this point. So usually you just check each of those columns one by each using discretion. So for passenger ID now, their passenger ID will contain unique identifications for passengers. So really there's no insight in that column. You don't need to use it in your model, and then you don't need to do any manipulation on it. Right, then your survived column is your dependent column. That's what you want to use to create your insights. You want to know if a passenger on that ship survived or not. If you read the overview, you get better understanding of what the competition is all about. But in the competition, you are asked to determine the level of survival of passengers using this data that are presented, right? So this would automatically become our dependent column, our dependent variable. And it's necessary you just run a check to see, okay, what type of values do you have in that column? So to do that, you call up your table, which we have named Titanic train. So Titanic train, that's the table name. Now you need to call up the column. Call the column, you use a block bracket and the column name within that block bracket. Survive. Right, so if I run this will give me a list of all my values in the column, right? But I want to see the unique values in it. So I'm going to call the unique function on that. Right, so you can see my column contains just zeros and ones, right? So zero, if you read the overview, zero means did not survive, one means survived, right? So next thing to do is to check up on P class column. What does P class column mean? And what are the unique values in it? So I'm just going to duplicate this and change what is in it to P class. So P class has 3, 1, 2. It's also necessary you check on the overview to understand the meaning of those variables. So just go to column. That should be under data description. Okay, training. Oh, sorry. Data description. Give me more information. Okay, yeah. So this is what we are looking for, data description. So under data description, you can see the columns and their definition. So P class means the ticket class. And you can see we have 1, 2, 3. So 1 is first class, 2 is second class, 3 is third class. Then you have sex, ages, and the rest of that. So the definition of each column will help you in understanding the values you are getting from your analysis. So I'm going to go now to so for name would be unique. So you would not need name in your model. For sex, you might need to check the sex type so that just in case it contains some values that are inconsistent, then you can replace those values. Okay, so our sex type contains just male and female, which is fine. Right, so let's check up on age now. So let's see age. Age is an integer type. So if we run unique on it, it will give us several values, right? So for an integer type, what you would likely want to do is to run maximum value on it. You want to know the maximum, the highest age, 80. You want to know the minimum age, right? So you have 0.42, you have decimal values in ages. You might want to round that up into months, right? So we might want to convert ages to months instead of using ages as decimal values. So if I convert, so age 1 would be 12 months, right? Okay, so in that case, we can just multiply each age value by 12. Let's do that. So this is age column. So we can say equate anything in age into the value multiplied by 12. So that would be months now. Right. So in our next column, so 80 years will then be months. Let's confirm this by checking up our age maximum. Great. We might still be having some decimal values. Let's see. right? So you can see we are still having some decimal values. We don't want to have decimal months. So to remove our decimal values, what we'll do is to round up those decimal values. So I'm going to call the round function on age. I'm going to call the round function on age. Where is that? Where am I? Okay, yes, yeah. Yeah, I already have it, so I'm just going to bring it up. So round my age, right? So if we do this now, let's check what we have in age. So all of this is just to, to curate your data to make it much more sensible. So now our ages is in months, right? And there's no decimal value anymore. But we still have an issue. We still have missing numbers in age, right? So to do that, oh, okay, let's just run this. Great. So our lowest age is 5 months. Our highest age is 960 months, which is still 80 years. So that's fine. So I'm going to so now I want to check up on null values in our ages, right? So I'm going to, let me explain this script to you. Right, so you have the Titanic age. Right. So these are our table, and then our column age, right? So this gives us all the values in our age column, right? But we want to see null values, so we'll call the isNull function. But isNull will evaluate as a Boolean, which is true or false. So if you call isNull function, it will give you the values that are not null, right? But on this function, I want to evaluate it into a Boolean and say when isNull is true, we'll use it as a filter now on our table. So this becomes a filter function into the same table name. Once you understand this simple concept of creating filters in Python, it's easier for you to create filtering and analyze on your table. Right, so, oh, sorry, you have to use square brackets, square brackets. Right, so this would give me values in my table where ages is not null. I mean, where ages is null, right? But I want it to give me for just age column, so I'm just going to specify the age column in front of it. Right, so for these missing values, we have about 177 rows that have their ages as null. So meaning that we don't have the ages of 177 passengers, right? We need to find a way of replacing this null value, right? And to do so, we can use the average age to replace this null value. So we need to know what the average age is. So to calculate the average age, we can just call the mean function. So we'll call the mean function on that column. So that is the column, and then we say mean, give us the mean value. Right, so this is the mean value on that column. We are just going to round this up as 356, 356. So let's assign the mean value into our missing function. I mean, into our missing, what's it called? Let's use the mean value to replace our missing ages. Okay, before we do that, I want to show us the normalization concept using the H column. Right, so to do that, I'm going to first of all sort my ages, right? I called the sort function on the H column, right? I've showed you this script in the previous cell. So just use the sort function from numpy to sort the ages, right? So having sorted the ages, we can determine the deviation from the mean, and then the norm values, right? So to call the standard deviation function, we need some other packages as well. Everything in Python is always from various packages. So you just know the package that contains the function you need. Right, so I'm going to call this now on the age function. Oh, sorry, I need to assign this to num, import this, and then call this, right? So if you look at the age column, right, you see that the ages are quite normalized. Let's rem the histogram so we can see it clearly. Right, so you can see that the age column forms that bell curve shape, showing that the data is well normalized and it's in a good shape for modeling, meaning that it represents a real life scenario. It's not like you have every of the ages skewed to the right or skewed to the left. So this helps you to get better precision in your accuracy. Right, so next thing we'll then do is to in our next cell, let's just replace our missing value. I want you to ignore this. Ignore this. Right. Okay, right. So we can see the values of our mean, standard deviation as well, right? By just calling the functions directly on them, right? We want to replace missing values now. So first of all, you are not replacing all the values in the H column. So we need to filter out the ones, the missing values. So I'm going to call all the missing values into all the rows of the missing values into a variable called age null. Yeah, let me just show you what we find in age null. Right, so you can see that it has given me just the ages that are missing. So these are the ones I want to replace. But so as to be careful as not to replace everything, I need to replace this within a loop. And to do that, I'm going to find a way of extracting the row numbers. Right. So the row numbers are the table index. So that's the need for this second function, which extracts the indexes into a list. Right. So if we run this now, all the indexes will be extracted into a list. Right. So we have that list, and we'll then use that list. We'll then use that list to replace our missing value. So we are going to do that in a loop. And to write a loop, right, you don't need this. Okay, let me just write it afresh. So to write a loop, we are going to use the for loop function. So just do for. And use any value. So I want to replace my table column value with this index if that'll be m equals. I'm going to replace everything with my mean value. Remember age is in months, and we already got our mean as 356. So this will be equals 356. Right, so once we run this, okay, this should be fine. That's just a warning, but that would be fine still. Yeah, let's check now if we still have any null value. Right, so you can see that we don't have any null value again. So all our null values have been replaced. Right, so anywhere we have null has been replaced with the mean age value. Right. Don't worry, I'm going to send you this script so you can practice on your own with description. So let's check our table now. Right, you can see age is complete. SB is number of siblings for each passenger is also complete. You can just see what SDL, what that contains. Right. Okay. So it's just giving us count of number of siblings for every passenger. Okay. Nice. So that column is fine, and we'll add it. Then part two is complete. Ticket contains ticket numbering or ticket information, ticket number. So the ticket number of a passenger might not really have any information to give us about whether they survived or not. But let's just see what is there. It's an object type. So we'll call wow. So you can see we have many unique ticket numbering information. Okay. Yeah, we have many unique ticket numbering information. So this does not really make any sense to our data insight. So we are not going to include it. And then fare, that's the amount they paid for. Oh, okay. So this is in floating values, which is fair because um, this has to do with money. But we can round this up, say, okay, ticket fare to round to two places. So round to, let's see. Right. So ticket fare should round to two places since it's money. So let's just put it as two decimal points maximum. So you can see how to clean your data to make it ready for your model, right? So this makes more sense for our fare. Then the next thing is cabin. I want to check the cabin. After this. Yeah. So let's check the cabin. Let's see what's in cabin. Oh, we have a lot of null values in cabin. Um, let's see the kind of information that we have in cabin. Okay, cabin number. Okay. Let's see how many nulls we have in cabin. So let's create our filtering function. Null. Okay, we already have it in our next cell. Let me just show us how to write it again. Is null, right? Equal true. So this is a relational filter to say, okay, when is null is true, give me the corresponding table. So why do I keep using brackets? Square brackets. So give me the corresponding table when is null is true on the same table. So this will give you all the tables. What's up? Oh, okay. Is null function. You have to indicate the open and close brackets. Whenever you call a function, it must have a open and close bracket in front of it. Right. So this is giving us for the whole table, but we want to see just for cabin column. So we then specify cabin column right in front of it. Okay, great. So you can see that we have 687 missing values for cabin, right? So then let's see the values that are there. Let's see how many unique values are in there and how much information we can get from it. We have 204 cabin uh, information. Okay, let's see if we have unique values in cabin. How many unique values we have in it? So we'll call the unique function. Let's see the count using length of the array. Wow, we have 148 unique cabin numbers. I don't think this will present to us any unique insight as to whether they survived or not. So we are going to leave out cabin information from our model. Okay, right. So this is still checking up on cabin. Okay, so now let's check the last column, which is embarked. So embarked as S, C, and Q. Embarked is showing us the ports of embarkation for each passenger. So the various seaports where they embark from, right? And we have 3 categories for them. So that's fine. And we have just 2 missing values. Okay, so we can plot this into a bar using matplotlib function, right? So when you run this, you have this bar shown below. Okay, so from this bar, you can see that most people embark from the airports, right? And you can also see that from the number 644 passengers embarked from that port. So we have just 2 missing values. And it's just record number 61 and 829. You can determine those from checking up on is null or is NA. Is null or is NA, right? Okay, so we'll just replace them with there's more probability that those other 2 people will come from the port that has the highest passenger. So we just decide to replace it with the same port that has the highest passenger. Okay, nice. So now that we have, we can check our data now to see if it's complete. Right, so you can see that it's complete except for cabin, but we are going to drop cabin because more than 80% of the values are missing. So it's going to skew our analysis if we decide to replace the values. So it's just like when you are trying to form a meeting and there's no quorum, you can't hold that meeting. So the same way, you are also going to just decide to drop columns that have more than 80% of their values missing. So to drop the column, you just call the drop function and specify the column name. Then you also indicate the axis number. So once we do this, cabin is dropped from our table. We're also going to drop tickets as well. Remember, it's just an ID, so it's not going to be needed. Then the sex, which comes as male, female, we are also going to change that into the respective index number. Okay, so we'll call the codes on the category name to change it into index numbering. So instead of male, female, we have 0, 1. We also did the same thing for embarked. So in embarked, we have SC. So models work better with integer values than with string values, especially if you are using logistic regression model. Right, so once all of that is done, we can now call a correlation function on our data. Right, so observing this correlation function, we can determine variables that are very significant to be included in our model. So both the positive and negative correlation are very important. They only show different direction, but as long as there is a good value in that correlation value, then you must include that variable in your model. So from this, you can see that the sex is having a very, very high significant value to your survived column. You can also see that number of siblings, I mean, the fare they pay, the port they embark from, and some other, and the P class are very, very significant to our model. So in that case now, we can then determine our X variables and our Y variables. So automatically, let's take this out so we can, yeah. Okay, right. So automatically, your Y variable is your survived column. Then your X variable, right, would be the variable names that are significant in your correlation values. So I'm going to start from the most significant to the least significant. So from here, you can see that the most significant is sex. So I'm going to put sex first. Sex, then fair. Then embarked. Okay, no, P class. P class. P class, then okay, P class is even more. Okay, fair, then then embarked before age, embarked, then age, then number of siblings, then hatch. Right, so this is going to form our X and Y into our model. So we'll just declare those. And now we need to call the function for our model. So because we're predicting a class type of insights, we are going to use logistic regression. If you're predicting value insights, then you would use simple regression or linear regression. So let's run our model. You just need to call that off. So this next cell divides our X and Y variables into size of 70 and 30. So this test size here indicates 0.3, then automatically train size will take 0.7, which is 70%. So I'm going to run this now. I'm going to run my model on my data, right? Now that I have the model on my data, I'm going to run the predictions on my test. Right, so the predictions is completed. I'm just going to run to check my accuracy score. Great, so you can see our accuracy is 79%. This means that when that model was run on the test data, 79% of the test data yielded the same result, so correct result. So this is how to run your logistic regression model on sample data. You can see bulk of the work goes into the data preparation towards fitting the model on the data. So just like we did in this demo, you have to check every of the column, check for missing values, and use your statistical understanding and concepts to replace those missing values and null values. Ensure all your values are complete, and then just simply call the modeling function. Right, so that's all on logistic regression on Titanic data. I'm going to send you this script so that you can run the data as well. And this way, you've been able to participate in simple competition model for running data. This also applies to real life scenarios. You're also going to just observe and analyze the data just the same way we have done in the demo session. And you can see it brings to bear all the things we've been learning in statistical concepts at the beginning of the class. Right, thank you.